Hello, I'm Kip Carmen with Veracity Networks, and today we're going to talk about SD-WAN. Software-Defined Wide Area Network is a transformational approach to simplify branch office networking and assure optimal application performance. Some of the benefits are simplifying your branch network with faster deployment, simplified configuration, orchestration, and ongoing monitoring with centralized troubleshooting. Seamless failover allows worry-free reliability. SD-WAN can support all of the data and internet connections in and out of your business. In case of failure or congestion, the system switches to the fastest and most logical connectivity route. This eliminates dropped calls and slow speeds. We can cut cost with SD-WAN, which allows your business to replace expensive MPLS or multi-protocol label switching for voice and data services. The two bandwidth providers delivering seamless failover work at a fraction of the cost of traditional failover strategies. Better your user experience with SD-WAN that has the capabilities of application prioritization and increased visibility into network performance and analytics. As a quick review, SD-WAN provides end-to-end visibility. Have visibility from the branch to Veracity's hosted data center or between multiple locations. Performance benefits are that you receive reduced packet loss, jitter protection, and dynamic packet steering to Veracity hosted data center or your other locations. We can optimize your application performance with direct, secure access to enterprise and cloud applications in real time. End-to-end protection means we provide you with the ability to properly troubleshoot and pinpoint issues should they arise anywhere. SD-WAN, an alternative to your normal failover strategy using WAN link redundancy or dynamic routing protocols like BGP. SD-WAN, Software-Defined Wide Area Network. Software-Defined Wide Area Network takes into account hardware equipment that it gets placed on-premise at the customer's location, and it takes advantage of software development and advancements to realize a better redundancy strategy. Next, what we'll do is we will jump into the Orchestrator. This is where all network administration happens. So you'll see here, this is the landing page for the administrator. Down here in my dashboard, you'll see that there are multiple different references to different locations. This is where a customer that has multiple locations, retail offices, could jump in and see all the VeloCloud devices. So if I click on Executive Conference Room, this is a VeloCloud Edge device that sits in our office. You'll see here that as we drill down into that particular VeloCloud Edge device, that we have three data connections. One's called Off-Campus Telecom, the other one is Veracity Networks LLC, and the third one is for AT&T Wireless. Now, keep in mind that we have an active primary and an active secondary. You can see what the status of the communication between the edge device and the gateways are, and what the status of the health of the IPsec VPN connectivity. You'll see here that they're on the interface is WAN type, and then we have gigabit Ethernet 1 and 2, and then we have this third connection that's specifically in standby, and we'll talk about that in just a minute. Over here to the right, we see throughput and bandwidth, so that you can actually see how much throughput and how much bandwidth is available or being used by each respective circuit. And as we expand this option over here, you can see here that we're actually monitoring and have real-time view of packet loss, latency, and jitter. And all of those, for a network administrator, allows you to jump in and do a quick view and determine if the health of each respective data connection is what you should be expecting. Clicking through, we have QoE, which means quality of experience. You'll see here that we have the before and after and each respective data connection. So the Veracity Networks LLC, Off-Campus Telecommunications, and the AT&T Wireless. The reason why the AT&T Wireless is showing red or critical is because it's in backup state. We will only send traffic over it if we lose our primary and secondary data connections, and it's set up and designed to do that from the beginning. These quality scores over to the right refer to the actual quality of the circuit, and then the quality score after, when it goes through the software-defined WAN wide area network VeloCloud Edge device and it implements forward error correction and link remediation, will actually smooth out the quality of that data circuit in the aggregate. So you could potentially have off-campus telecom reporting an 8 out of 10, and it would show in a yellow, meaning it's a poor quality. But because we're able to route around that, the aggregate improved experience through the VeloCloud enhancement would actually result in a 10 or a 9 plus in the quality. So as far as the end user is concerned sitting behind your network, even though you have a circuit that is not performing very well, the result for them is that the quality will still appear as if it's better. You won't be down, or you won't experience drops when we begin routing around that, because we do what's called packet duplication, and it's sub-second. So within 500 milliseconds, when we detect a circuit is down, that we have latency jitter or packet loss, we will route around that. But those sessions will not drop because we duplicate those packets and send those up to the gateway. So the last item that I'd like to talk about as far as the orchestrator is concerned is going in and actually taking a look at live traffic running across the primary and secondary circuits. You'll see here that Veracity Networks LLC is sending constant communication between the edge device and the gateway that we referenced in the drawing. And one of the things I like to do is demonstrate what a phone call looks like between a phone that is connected behind the VeloCloud. So we have a Polycom IP handset that plugs into a premise-based session border controller in Edgewater, and then that Edgewater is plugged into the VeloCloud edge device, and it has a public IP address on it. So I just made a phone call from the phone out to the public switch telephone network, and you'll see here that off-campus telecom is now carrying that voice traffic. We went from next to no traffic to 34.41 kilobits per second, and that's UDP traffic, and UDP is the connectionless protocol that's used when we're doing voice over IP calls, when we have an active call where we're exchanging voice communication. So what I demonstrate now is I will actually, on the VeloCloud Edge device, I will go physically to the secondary connection, and I will unplug that connection, and the call in a normal scenario doing BGP or doing WAN link redundancy would fail. But you'll notice here that off-campus telecom, where we were formerly carrying all the voice traffic, you see that there's no additional traffic going through there. It basically shows that there's 0 bytes because we've lost connectivity. And Veracity Networks LLC actually picked up that voice communication, and the call continued being processed. So that all happens seamlessly. With WAN link redundancy and or maybe BGP, where you're having latency jitter or packet loss because of some type of network event, the network administrator would have to go in and actually take that out of service. With SD-WAN, this all happens and is built in with the software application taking that into account. Now, I referred earlier to the AT&T wireless card that's sitting in backup. We can plug in, whether it's Ethernet based or USB based on approved devices, a connection that is backup to take into account that maybe you have a fiber seeking backhoe that goes in and cuts all your connections, and the result of it is that both your primary and secondary data connections go down. So I can unplug the circuit associated with Veracity Networks LLC, and you'll notice that now becomes critical and down, and the AT&T wireless card within a matter of a few seconds picks that up, and voice calls begin routing over that, which for a business is really important. You will not experience a disruption in communication. You'll be able to continue making and receiving phone calls. You will be able to continue processing credit card transactions, and this system is set up to send out alerts, whether it's email or SMS, so that your managed service provider or your IT vendor or whoever's responsible for managing this will be notified, so they can reach out to their carriers to launch a service ticket to get these systems restored. So that, in a nutshell, is the power of doing software-defined WAN. I mentioned earlier that doing either BGP routing or WAN link redundancy would result in a failure on the first circuit going down, and having to reestablish all those sessions. With SD-WAN, I have now plugged in one of those circuits, and you see that AT&T will go from being the active data connection to inactive, and Veracity Networks LLC will become the active session, and all of the voice traffic will fill over to that. And I can also subsequently plug in the original circuit, which was off-campus telecom, and those will become aggregate bandwidth for all data communications. The AT&T will go back into a backup state, meaning we're not sending any data over it any longer. And throughout this entire process, those voice calls, that data communication that's going on, will be preserved, and there will not be a disruption. So you can see on Veracity Networks LLC, we're now sending about 40K of UDP traffic, which means that voice call was preserved through the primary failure, the secondary failure, over to the AT&T wireless, and then it began failing back, and we did not drop it throughout the entire process. So that is really compelling and really powerful, and a great selling point for network administrators and businesses that have that demand better than your traditional 2 nines, 3 nines, or 4 nines up. So in summary, SD-WAN improves on traditional failover strategies. It makes the process for failover less complicated and more seamless. It takes into account prioritization and real-time applications and preserving those in a failure event, but it goes beyond that and actually looks upstream for latency, jitter, packet loss, and uses link remediation to route around that. So we feel like this is a valuable product, and rather than it being a nice to have, it's becoming needed. It is needed infrastructure for customers who have a primary and secondary data connection or have a requirement for greater uptime.